has gone bigger and bigger. It has grown, and today it stands majestically as one of the leading colleges in Odisha. Also, it is known for its academic excellence and quality teaching. Congratulations for that, and also congratulations for organizing such a uh, webinar, which actually takes enormous amount of effort, hard work, and cooperation. Thank you so much. Okay, so today I'll be speaking on the plastic pollution of oceans, so which is a very important topic. And I selected this topic, although I'm not doing. Can you kindly share the screen? Please enable sharing the screen. Yeah, you cannot. Yeah. Yeah. Okay. Okay. So yeah, thank you for doing that actually. So I selected this topic because of the fact that the plastic pollutions, it's a very serious kind of an issue. For some reason, the environmental community have not been kind of focused much into in this topic in the last couple of years. There has been some amount of research that has taken place, quite a good amount of research in the last 10 to 12 years. And also the general public is not aware of this problem. So now I'm just going to go over some very basic things. What are the type in this today's presentation? I'll be just telling you the type of plastics, how plastics affect the zones, different zones of the environment, that is hydrosphere, atmosphere, and biosphere. Now, plastics have replaced metals in many of its applications since the last 70 years or so, and there are 100 different types of plastics which are produced all over the world. Now, plastics, as you know, are the synthetic polymers. Yeah. Can you all see the screen?
Yes.
Okay, great. Thank you so much. Okay, so plastics are synthetic polymers made by linking hundreds to thousands of organic molecules, basically the subunits by a strong covalent bond. And there are many types of plastics which are made. Now, some of the examples of plastics which I want to give you here, tell you, of course, all of you know this. Largest market share, however, belongs to the low-cost thermoplastic polymers like polyethylene terephthalates, PVC, that is polyvinyl chloride, polypropylene, polystyrene, and so on. Okay. Now, during the production of plastics are made from the monomers, which are petrochemical based. And during the process of producing plastics, large quantities of gases such as carbon dioxide, methane, lower molecular hydrocarbons are emitted into atmosphere. They are greenhouse gases responsible for global warming. Okay, so let me go to the, okay, just 1 second. Okay, now general types of plastics, some of these common type of plastics we use in our day-to-day applications. High density polyethylene, examples, snack food, non-carbonated bottles, garden furniture, buckets, and so on. Low density polyethylene, like wires, packaging films, bubble wraps, shopping bags, and all that. And then polyethylene terephthalates, PET, water, soft drink, and beer bottles. Some of the examples that we all know we use very much. Polypropylene plastics, some of the applications of polypropylene plastics include ketchup, syrup bottles, biscuit wrappers, and so on. PVC, that is polyvinyl chloride, floor covering, windows, door frames, wires, and so on. How plastics harm the earth. So we'll just talk on these things. Plastic affects all zones of the atmosphere. Atmosphere, all zones of the environment like biosphere, hydrosphere, and atmosphere. As I said before, during the production of plastics, large quantities of greenhouse gases are emitted into the atmosphere. But today in this talk, I'll be talking about the plastic pollution of the oceans. Now, here, okay, I'll just give you some numbers. Most of the plastic waste, okay, let me tell you here actually. Between 50 to 55%, what happens to the plastic waste? About 50 to 55% plastic are landfilled globally. In the USA, however, 75% of the plastics are landfilled, and about 25 to 30% plastics are incinerated all over the world. That is a plastic waste. Only 8 to 10% of all plastic waste are recycled. So look at this number, only 8 to 10%, and about 10 to 15% waste discarded into the environment. They are kind of recklessly kind of discarded. Now, how much quantities of plastics go into the ocean? So before that, I'll tell you how much plastic is there in the ocean. According to one estimate, there are 76 trillion pieces of plastics in the ocean. 76 trillions, and 1,000 billion makes 1 trillion. And out of which 25 trillion plastics, 25 trillions are macroplastics, large pieces, and about 51 trillion are microplastics. That means they are of 5 millimeter or smaller size. Okay, so you can hear me okay. Now, the amount of plastic that go into the ocean are estimated about 2 billion kilograms that leak into the marine environment mostly from the land-based sources. Now, this is equivalent of kind of, there is some interesting analogy. It's equivalent of dumping a garbage truck full of plastic into oceans every 1 minute. Now, about 80% plastics entering into the oceans are obviously due to the poor waste management, and there are also other factors like fishing, storm winds, littering, and so on. Now, the countries that pollute most are China, followed by Indonesia. These two countries account for about 35 to 40% pollution, plastic pollution of ocean. Now, plastic debris from, okay, here, I'll just, plastic debris, they kind of, include all these kind of shopping bags, bottles, beverage bottles, and all that, fishing nets, fishing gears, and roadside debris. Now, regarding the roadside debris, also it's interesting to note that this is an estimate, about 8,000 tons of roadside debris, mostly the tires, pieces, they are blown into the oceans every year. What an amount! Is really a serious issue. Now, let's see. Now, plastics in today's presentation, I'll talk about the decomposition, the chemical reactions, how plastics break down. But before that, its harmful effect. Okay, harmful effect on the ecosystems, in the environment, and human health. Okay, now when plastics enter into the ocean, the largest pieces, they kind of, they sink to the bottom of the oceans, and the smaller pieces, they float on the surface, either below the surface or on the surface. Now they collide, they break down by the ocean currents, by the waves, forming smaller particles, smaller pieces. We call it microplastics, which is, as I said, 5 millimeter size or less. Now, some of these plastic patches are kind of, are notable to mention here. Actually, they have been observed. They collect in large patches. You see the pieces of plastics floating in the oceans. One such accumulated large patch, which is quite well known, is called Pacific Garbage Patch. So it is half the size of India, 6 lakh square miles, extending from California to Hawaii. And there are many such plastic patches that can be visible from the plane in most of the oceans, mainly in Pacific Oceans and then also in Atlantic Ocean. Okay. Now, okay, this I just say. Now about the pathways, how plastics enter into the ocean. So one thing I just want to mention here about the 10 to 12, 10 to 15 large rivers, mostly located in Asia, Africa, and South America. They kind of carry these plastics debris from the land into the oceans, and this is a large amount. Proportionately, this accounts about 60 to 70% plastic pollution of ocean. Okay, another source, as I said, is the cyclones, storms, and high winds, which carry kind of blow the lighter plastic waste, and the fishing nets, the fishermen, the fishing community, they kind of dump their plastic kind of fishing nets, fishing gears, and kind of equipments when they cannot use it into the oceans. Another source, which would be a major source of plastic pollution of oceans, are these ships, the huge cargo ships and the cruise ships. Thousands of such ships fly every day, so they kind of also discard the waste into the ocean. Now, according to the estimate, another estimate, it's all interesting numbers I just wanted to share with you. It is kind of predicted that in about 25 years from now, the amount of plastic waste in the ocean would exceed the total amount of fishes in the oceans. So this is a terrible situation. Okay. Now, how it affects the sea creatures, sea animals. So I'll just tell a little bit on these things actually. So fishes and other marine species kind of, they get entangled by the plastic nets, by the plastic substances, and then they ingest smaller particles, the microplastics in the oceans, and kind of, that affects their kind of, body, and actually many of them die. I'll tell you the harmful effects from there actually, but at this point, let's go into some other kind of slides which I just wanted to see. Okay, now how the human beings are affected, mostly through the food, that is seafood, water, and air. Because mostly through seafood actually. Small organisms, they consume plastics, microplastics, the smaller particles, the smaller size pieces, and fishes and other large species, they eat small marine organisms. So it, in a way, it kind of, it migrates within the marine species, and toxic chemicals enter into their tissues and enter into human food chain. Okay, now it's interesting to discuss something about the types of chemicals. So I just wanted to share with you some of the chemical substances, the plastic additives. I'll start with the additives. So there are three types of kind of chemicals related, three types of related plastic related chemicals. So let's go over all these things. Additives. There are many substances that are added into plastics, and such as to enhance the properties of the plastic, the qualities during the productions, such as colorants, that is mostly many of them are pigments, and to enhance the transparencies and to prevent the oxidations, So these are the objective for which all these additives are added. Antioxidants, lubricants, then additives are also incorporated into plastic to enhance or to produce the resistance to degradation by radiations, ozone, and temperature, mold growth, that means growth of bacteria and mold, resistance to humidity, to increase, enhance the thermal, electrical properties, mechanical properties, and also many substances that are the plasticizers are incorporated into plastics for not only to quality, not to improve the quality of the plastics, but also for to kind of prevent the brittleness of the plastic, just to enhance the kind of this fluidity. Now examples of some of these additives are okay now here, yeah, metals. Many metals are added into plastics for the reasons, as I said, as colorants, plasticizers. I'll just 1 second. Let me okay. So let me complete first here what I started here. The types of chemicals. So I would classify the chemicals associated with plastics into three different categories. One are the plastic additives, substances which are added, and they are, most of them are physically incorporated. Only a few types of substances, especially the bromo derivatives, some of these kind of flame retardants are chemically inserted into the polymer chains. Okay. Now I'll give you some examples, specific examples of additives, and but let me go to the second type of substances. They are plastic monomers and the degradation products. Okay, so there are many plastic monomers kind of are there actually. I have a large list, but I'll just go over some selected compounds and substances that are really toxic, very harmful. And the third category of substances are the hydrophobic non-plastic pollutants. These substances, these chemicals have nothing to do with the plastic. So how do they come? How are they produced? How are they related to plastic? Because these are the environmental pollutants. They flow into the oceans by the rivers. As I said, most pollutions, the source are the large rivers that carry all these land pollutants from the land. So these are the environmental pollutants, such as uh, fertilizers, pesticides, herbicides, and other environmental pollutants. They float into they go into the ocean, they adhere, they kind of accumulate, they adsorb over the microplastic surfaces. Because the microplastic surface, they have high surface area and they are hydrophobic. So I'll give you a list of such, non-plastic pollutants. They are of equally very toxic substances are there. So I'll just go over some of these chemicals as we move on. Okay, now as I said, okay, additives, examples of additives. I covered these things. So metal salts, colorants used as like metal pigments. They are salts of uh, chromium, lead, cadmium, mercury, manganese, aluminum, and other things, cobalt, and many such metal salts are added. Plasticizers. Now, bisphenol A is really a very toxic substance. I won't say toxic, but it is an endocrine uh, disrupting substance, and many phthalate esters are added. Flame retardants are other examples of additives, such as brominated organics. That is, I'll give a list of some of these brominated organics. I'll just share with you the chemical structures. So these things, the toxic effects also, melamine, and many organophosphorus compounds are also added as kind of as plasticizers. Okay, so let's go over the. Okay, this I have just shown. Okay, next. Now monomers. Some of the plastic monomers that I would say include common, originating from plastics. Vinyl chloride, which is a confirmed human carcinogens. Vinyl acetate, acrylonitrile. Nitrile means organic cyanide. Acryl group attached to the cyanide. Styrene, CH2, CH2 double one CH attached to the benzene ring. Methyl methacrylate, 2-methyl-1,3-butadienes. So some examples of these plastic monomers. So currently, right now, I'm discussing about the types of chemicals associated with plastics. They kind of leach out from plastic, and so they are degradation products of plastics or plastic additives and so on. Okay. The third type of chemicals, which is of very important, we cannot kind of overlook them. These non-plastic chemicals, hydrophobic. So there are, most of them are hydrophobic, non-plastic pollutants. Okay, they come from they are absorbed from the surface from surrounding ambience. So they include fertilizers, agricultural products, petroleum residues. Okay, here. Polynuclear aromatic hydrocarbons, PAH, which are the coal, heavily aromatics, coal tar, coal products. Then PCBs, polychlorinated biphenyls. Now there are some interesting examples which I will give you. Phthalate esters, of course, they are the plasticizers, but they are also the common environmental pollutants. So they kind of adhere, accumulate on the plastic surfaces. Nitrosamines, polychlorinated dioxins, and dibenzofurans. Now in this context, I'll just give you some examples here. Now organochlorine pesticides. Now you'll note that many large quantities of pesticides are used in agriculture, because you'll see there are thousands. There are, in fact, in the USA alone, there are about 50,000 formulations, and every year, new formulations, new type of pesticides are being produced. And many of the very common, popular, well-known pesticides of yesteryears are banned. They are not used anymore. So if you ask the question, how do they come? If they are banned, where do you find them? The answer to that, I'll just give you one example. DDT, which was at one point, it was #1 chemical in the world in terms of its productions and use. Of course, it kind of eradicated malaria and all that. But DDT was found to be kind of highly toxic, and that is dichloro, diphenyl, trichloroethane. So it was replaced with other groups such as methoxy group, substituting some chlorine atoms. I will not have time to show you all those reactions and structures. I'm just giving you some examples of pesticides, different type of pesticides. They are all agricultural substances. Almost 80 to 90% pesticides made today are used in agriculture. And remember, in the world, there are over 200,000, that is 2 lakhs, different grade of pesticides, and toxic substances are being replaced with new formulations and all that. Organophosphorus pesticides, they are very equally, they're very toxic substances, widely used, and their toxicity can vary. So these substances are very much present in the environment, actually. Now, many of these pesticides, which I'm just talking about, including carbamates, so you have the structures, they are all produced in millions of tons all over the world. Some of them are banned, but still they persist in the environment. For example, there's many chlorinated pesticides such as dieldrin, aldrin, etc. They do not degrade that fast. DDT, methoxychlor, and so on. Triazine, this is another substance of concern actually. It has low toxicity though, but it is widely used in lands based in the southern part of USA, in Texas, Florida, and places like that. So there was a EPA conference on these triazine pesticides. PCBs, this is another. Now, these substances have been detected. They have been found to be adhering, accumulating on plastic surface in the oceans. PCBs, polychlorinated biphenyls, that is, there are high chlorine substitutions. And now they are no longer kind of used because their use is banned, but still they persist in the environment because most of the PCBs waste were dumped, they are landfilled, and so they do not need that cost. Okay. Now, polynuclear aromatic hydrocarbons, I mentioned, some of they are all coal and coal tar derivatives, phthalate esters, and all that. Now, polychlorinated dioxins and dibenzofurans, I'm just telling you a little bit about these type of substances. Now, they are kind of, they're highly toxic, obviously. But one such substance, all of you are pretty much familiar with, that is 2378 TCDD. That is not found. That you don't come across. It's highly toxic substance, which was used in the Vietnam War under the so-called Agent Orange. Of course, that was kind of, that was mixed. That was for a different purpose in the military warfare. Just when US troops are fighting the Viet Cong guerrillas, they used kind of, chlorophenoxyacid herbicides as defoliants. And so they mixed a very small quantities of 2378 TCDD, tetrachlorodibenzoparadioxin and dibenzofurans. So those specific isomers are not there, obviously, but there are also many other isomers, that is chlorinated dioxin and dibenzofurans, that have been kind of detected in very small quantities in the on plastic, microplastic surface. Okay. Now, seafood contaminated with, seafood contaminated with such toxic chemicals can cause serious health problem. Okay. Many such chemicals. Okay. Now, what are the health problems? We'll go over some of these health effects. Many are carcinogenic, cancer causing, teratogenic. Okay. They can cause birth defects, and many are toxic. Okay. So now how these kind of toxic substances enter into human food chain? Of course, through the consumption of seafood. So I'll just give you some examples of effects. Okay, plastic contaminated seafood. Okay, now let us start here. Just give me a minute here. Okay, here. Endocrine disrupting substances, EDCs. In the last 10-15 years, there has been lots of kind of the research going on in this kind of in studying the health hazards from these kind of substances. They're associated with hormonal disrupting properties. Now, what are the effects? They can cause breast cancer, that is chronic ingestion of seafood, can cause cancer, different type of prostate cancer, breast cancer, testis cancer, genital malformations, infertility, metabolic disorders. That means the diseases relate with metabolic disorder such as diabetes, obesity, then also asthma, then kind of neurodevelopmental effects like autism, developmental effect, learning disorder, and all that. So that is endocrine disrupting substances. Now, just let me. This is one substance which is very widely kind of discussed everywhere. Bisphenol A. This is a very common plasticizer. It was used, or it has been in use since 1960s. So it is produced by the reactions. Two phenol molecules reacting with acetone, bisphenol A, which is a common plasticizer. So now this plasticizer is used in polycarbonate plastics, food packaging, safety equipment, and components of epoxy resins. Okay, the another type of substance, phthalate esters. Okay, now phthalate esters, they are the esters of phthalic acids, like that is 1,2-benzene dicarboxylic acids. Now, what kind of phthalate esters? Such as dimethyl phthalate, diethyl phthalate, N-dibutyl phthalates, and there are about 9 to 10 such phthalates which are listed as priority pollutants by the US Environmental Protection Agency, and 4 phthalates, diethyl, dimethyl, N-butyl phthalate, N-dibutyl phthalates, and butyl benzyl phthalate. I have not written here actually. So they are kind of regulated substance that is by regulated under European Union Act actually. So that means their concentration in the plastic as additives cannot exceed a certain kind of limit. So that is all this thing. But in the USA, I'm not sure about if there is any such kind of regulations. However, USA regulations pertaining to the environmental pollutions, there are regulations for the drinking water, wastewater, and so on. But I'm not sure if there's any regulations that kind of applies to the additives amount in the plastic. Okay. Now, some other endocrine disrupting substances are brominated compounds. They are not plasticizers, but they are also brominated flame retardants. This is a very common substance, dibromophenol, 2,4,6-tribromophenols. Okay, now this is one thing which is there has been a lot of articles on these papers on this polybrominated diphenyl ethers. So I'll show you the chemical structure of this compound, these type of compounds. Just let's say here. Okay. Then hexabromocyclohexadiene. Okay, then dimethyl phthalates. These are some of the endocrine disrupting substances. This is just some chemical structures. There is a lot of studies on these di-N-butyl phthalates. Okay, they have low toxicity, but they are kind of this thing. They have toxic effect. Bisphenol A. So that is 2 phenol units bind to kind of attached link to acetone. Okay, now toxic effects. This is caused in humans. Ingestion of seafood contaminated, okay, microplastic particles and associated chemicals. Okay, this is polybrominated diphenyls, heavy brominations. Poly means there are kind of substitutions, 6 to 8 to 10 bromine atoms substituted, polybrominated diphenyls, then polybrominated diphenyl ethers. So these are the plastic additives. Okay, hexachloride. So these are some examples. I just gave you the structures. Okay, so let's move on. Okay, now the toxic effects and diseases caused in humans from ingestion of seafood contaminated with microplastic particles and associated chemicals. So I'll just go over some of the toxic effects. I highlighted the toxic effects of some of these endocrine disrupting substances, but now